Hey everybody, I'm Stefan, and little did my team know, but I came up with a name that they weren't expecting. But if you're a nerd and a history buff like me, you probably like Andrew Carnegie. Obviously, the invention of steel led to an entirely new kind of development of buildings and skyscrapers and higher density cities all over the United States. So that's just my little quirky name for our team. But you can see I'm the founder and my partner here of a company called Create, and we used actually our software as a service platform as one of the technology components that we worked with today. So you'll be seeing some of that. You can see it on the bottom here. This is a 3D GIS map with land use of every building in DC. This particular picture has a heat map of where all the retail density in the city is built out. So you'll see bits and pieces of that. We had an awesome team that we somehow wrangled and convinced to work with us, which I guess was about 12 people. So big shout outs to Melissa, Devin, Andrew, Susan, Sabi, Sean, Dan, and then the folks from my staff, John, Vanessa, Laura, and myself. So what our objective was to try and figure out a way that folks like myself, and my background is in real estate development, so I'm not an architect or a contractor, but I'm more on the owner-developer side, and I was constantly faced with these challenges like, okay, well, we have a site, then we need to figure out what the heck do we do with it in order to maximize the value, or we have a client and they need to build a hotel, and figure out like which site in the city and there's 138,000 individual parcels in Washington, D.C., can we site that building on in order to maximize their ROI and achieve all the rest of their business goals and reach an achievable building program. So we actually, this is hard to see, but I mean, we're really trying to get to the processing of not only GIS data, but also different kinds of business requirements that we can generate, as well as constraints based on form-based code, primarily from the zoning side, not on the building code side just yet, to reach an instant indication of design feasibility. So for any site in the city, how can I really just instantly generate a massing model that would give me some indication as to what my yield would be? And so what we initially started to do is, if anyone here has used the Unuma planning system, that was the technology where we're going to integrate and do some web service calls to try and just send out our requirements and then pull back in some, leverage that procedural generation and then pull back in the 3D building geometries and then superimpose it on our map. And really, if you've seen or used this stuff, you can see it in the top right here. It will generate an actual 3D stacking model and get it on our virtual globe in order to reflect that real world position. And on the bottom right here, we had this whole big convoluted list of steps that we needed to do in order to try and wrangle the data between these two different sources and then kind of end up with the end result that we wanted. Well, unfortunately, we had some issues. So I was actually pretty happy because it took us only a few hours to figure out that this was not going to be the solution for us. So much credit to the team because we actually had about half the time because we had to start from scratch at about 2 p.m. yesterday in order to figure out what the heck it is what we're going to do. And really, through the course of our software development, we realized that we really don't like Google Earth. We think that plugins are going the way of the dodo bird, which you can see in the top right. And we ran into some other issues as far as the inconsistency between the programmatic building inputs and then with the building geometries that we would get back. It was really incomplete. We wouldn't get all of the information that we would need in a collada file if you are familiar with the GIS world. And obviously having to cope and deal with a lot of third-party proprietary technology was a little bit difficult for us to adapt. So we decided to say, well, screw it, let's throw it out and roll our own and see what we come up with. So Christmas came early on the bottom right. You can see the 3D Santa superimposed on the cesium globe. And we kind of took a step back and looked at, what are the different levels of detail that we can really need to step through and what requirements are needed at each level of detail in order to really kind of shepherd this through the whole process. So we looked at, okay, well, we have the building footprint, we have the lot footprints as a shapefile, and we have a few different constraints, both lot occupancy and front and rear setback, rear and side setbacks. There's no front setbacks in Washington, D.C. And then we could also work in the building height and further down the line the FAR, in order to reach a maximum development envelope. So we tried to kind of get as far down the line with the first step over here on the left that we could, and then we're working towards really getting a massing study that you're seeing as we kind of get a little bit more refined as to how we determine this feasibility. We're not trying to go and process the entire form-based code and get into building codes and all that kind of stuff and do code checking. Not really our goal, but something that is, other people are fortunately taking on rather than us. So with our second attempt, what we did is we actually used a lot of the bundled tools that are built into the virtual globe that we're working with, which is Cesium.js, which is an open source virtual globe and a web-based version of Google Earth that is actually a lot easier to work with, assuming you don't have an Intel graphics card, and actually write our own scripts for computational geometry to process that information and then work with the both X, Y, and Z axes through our GIS data to basically put the framework in place for automated building geometry, but allow users to go in and augment it so that if they wanted to, basically ignore a zoning rule. Well, we could allow them to do that, and then the logic in our system down the line will go in and basically tell them, hey, if you want a zoning variance, good luck, it's gonna take you 6 months and cost you 100 grand in legal fees, and even then it's a 50-50 chance you're actually getting anything done. So here's kind of what we came up with, and there's a couple screenshots, and Laura will show you the live version in just a second. But what you're seeing here is a neighborhood in DC, and this white parcel is actually our other partner's house. And we have a list of all these different rooms and things like that, but really what we're more focused on here is the XY coordinates of each of the vertices of that lot. And with a simple click of a build button, we have generated a wonderful looking purple building that is a potential skyscraper that could go on that site. I guess not a skyscraper in DC. Four-story row house, as opposed to a 2-story row house. So we've taken all those rules and we said, okay, well, this lot is shaped like this, but that geometry also has an R4 zone attached to it. So what does the R4 zone mean? Well, it means that you've got to contend with all these different constraints. And as a result, if you wanted to build out to the maximum density on that site, voila, one click, and that is the building model that you end up with. So Laura, why don't you take it away?
Okay, so this is in many ways the kind of the rough sketch of where we're going. And we had big dreams for Enuma, but we're really excited actually to just bring this into Cesium and own it. And so when we click on a building, and I'll just give you an idea of what our software does in a more general kind of way, you get like a whole lot of detail about that property. And so this is the detail that we'll be harvesting in order to figure out what kind of building can go on there, how big it can be, what the zoning rules are. And so, we sort of have this basic construct that we'll be able to work from as we develop this module. Okay, so some other things that we're doing, I'll hem and haw here. Some other things that we're doing that are really close, we're looking into more the financial analysis side in what you can put in a property and profit predictions. All right. So we've clicked on this property, and now we're at 3507T, and we're actually gonna drop this high rise right on top of Ed's house. There we go, and we have a little commenting here just so we see it's happening. And bear with me. Okay, it's gonna do a little refresh because I did zoom in. There's our high rise. Okay.
Voila, there it is.
For DC, that's a big building, so there you go.
That's one of the bigger, taller buildings in DC. But I mean, the concept here is that not only can we do this for one building, but we can do this for every lot in the entire city. We can do this for every zoning condition, if you want to do a planned unit development versus a simple variance, existing conditions, whatever it might be. This can be really extrapolated across all 100,000 plus lots in the city. So DC is one thing, it's pretty built out, but one of the places that we're looking at going next is Detroit. So you can imagine that it would be really interesting to see the entire city built out. I don't even want to imagine how many lots and just the amount of land area we'll need to cover with this kind of stuff. But that's it.
All right, thank you.